Okay, a little bit on magnesium batteries. I bought a bunch of stuff from Radio Shack when they were closing their stores, and it was all really cheap. And there's this Eton Blackout Buddy H2O light. It looks like this. Has a little plastic cover, but I took it off to show some things because I can't do things with two hands while I'm videoing. You can see there's three LEDs there, and what looks like a battery pack, and then on the bottom they have a plastic cover, I guess, to keep humidity out of the battery while it sits. So I took one apart, brand new. At the top here on the edges, I used these sharp cutters to cut away some of the plastic because there seems to be like a melted crimp on the edge to keep the battery from falling out. So I cut that real carefully, and pulling on the LEDs, you can pull the battery pack out. Now on this side you see copper, this side you see the white metal, which is apparently the magnesium, and then here you can see that there's 4 cells. Now I pulled one apart after the storm. I used a couple of these in my apartment when the lights were out for about 7 days, and you can see that this here is the magnesium plates, I believe, and I cleaned one up, and I cleaned up one of the copper plates. These are the other 2 copper plates. When I pulled this one apart, it looks like it had 3 cells. This one looks like it has 4 inside, because you can see the thickness of the magnesium plate. It's much thicker than the copper. It's stronger. This is more like a foil on the copper. And these were the pads that were in between. This one's slightly blackened, this one's heavily blackened. I don't know if there's added carbon on there because there's only 2 of them with that, and this one looks like it has some copper residue on it, maybe from transfer of like kind of electroplating, trying to go through this to the other plate, but it's just a fiber piece that holds the electrolyte once you add water. So here, got some water here, just tap water, and we're going to show this thing turn on. Let's see, how can I set this up? Let me see if I can use these as a little, okay, I'm just going to drop the water into here, let it soak it up. Now it says on the thing only a few drops. Seems to be more than a few drops. Okay, the LEDs just came on. There's 3 of them in parallel. You can see the wires on this side of the LED are taped onto the copper plate, and on this side to this magnesium plate, and then there's the layers. But she's pretty bright. I still have one a month later that's still emitting light above my cat dish, where I gave her some night light while we were out of power, and it keeps on going. Seems like they're inconsistent as to how long they last. Says only 72 hours on the package. On this part of the package, you can get these on eBay. If you look up Blackout Buddy H2O, and you'll find more links to them than looking for the Eton thing. And you can see one of these LEDs is already out for whatever reasons, and it seemed to be consistent with some of these already. If you wiggle it around, it comes back on. So it's possible the pressure of being inside here helps hold things together. So if I squeeze it, it works. Okay, so now what we're going to do is hook up a meter and see what kind of voltage is coming out of these. Let's see, voltage, and let's see, we're just going to put the negative on this side. Actually, see how I have it marked red? According to the LEDs, the positive should be on this side. So let's connect our negative here on one of these LEDs. They're all in parallel from what I see. And the positive will connect just to this one here. And we get 2.685 volts, around that area, but it's enough to light these LEDs pretty good. Over the 72-hour period, they do degrade some, and the one that's gone on for over a month, if I add a little bit more water to it, it kind of douses out the light. You come back 15 minutes later and she's back again. So now what I want to do is I'm going to cut these LEDs off of here. I'm going to give the camera a rest there for a second. We're just going to cut these off so we can measure the unloaded voltage of this battery. Alright, so here are the LEDs. I'm going to use them for something actually that I need. And that's why I left a little bit of leads on there. Okay, now we hook up our meter again. I don't know what sort of chemical they put on the pads that are in between, the fibrous pads, when you add water. Wets the electrolyte, but here we have 4.1 volts coming out of this thing. So they do corrode. This was one that I tore apart after it stopped working, period, no matter whether I wiggled the LED. So I took it apart, and there's some heavy corroding of the panels. This is a copper panel. This is the outside of the copper panel where the LEDs were, and then if you look at the other side, pretty heavily corroded. The magnesium plates, they're corroded. It looks like one side is differently corroded than the other, and similar here, but they clean up. I just took some 180 grit sandpaper and acetone because there was some tape residue on there to get that off first, and then just sanded them, and they come out clean. So the cells can be reused, and you could, if you want to do experiments, these things can be had on eBay for $3-4 bucks, up to $10 bucks, depending on who you get it from. And you can cut this stuff into strips and make your own batteries. Experiment with different kinds of electrolytes and different things. But anyway, it's down 3.99 volts. So that's the first I've tested it before taking apart a clean one. I imagine it'll all look like this. Be interesting to see if there, of one that hasn't been used, if there's some kind of carbon on these, but only 2 of them have that, and the other one is clean. So I'm not sure what's going on there. It might have been something to do with the sandwiching, and maybe these were working more effectively than this one, and that's why the light went out sooner than expected and didn't come back on. Anyway, just wanted to show this. Back up to 4.125. The water in the electrolyte, I guess it needs to expand through the fibers and settle and come to a point of where it's not settling anymore. But so far it looks like there's 4 cells, so below 1 volt per cell on this particular one, and I've seen some magnesium batteries done on YouTube that get over 1 volt per cell. So just wanted to show this, and if you're interested in messing around with magnesium batteries, look for the Blackout Buddy H2O. Thanks.